We are and what we are. We're the electric sport bike team. My name is Michael Malko, and I work with three more students, which are Aslan El-Khaizi, Patricia Peskevich, and Jembus Rage, who unfortunately couldn't come here today because of job. And so overall, what we are doing in this project is we have this frame from Yamaha 1986, and we are making it electric right now. We cleaned off the rust and all the engine components from electric internal combustion engine components, so all we have right now is just the frame and wheels. And during summer one, what we have been working on is design of the motorcycle. What you see right now is the 3D design of the, it's like very good approximation of the frame that we actually have today. And so for the electric motorcycle, in order for it to function for any electric vehicle, we need five major components. They are first, brushless direct current motor. That's the type of motor we use in our system because it's the most efficient electric motor so far. We're gonna use 20 kilowatt option because it's gonna be able to push the motorcycle to 60 miles an hour to be able to move on the highways. Then the next major component is the controller, which you can see over here. The controller is required to program the motor and regulate the speed of how fast it's gonna go and how much torque it's gonna provide. Third component is gonna be the batteries. You can see we're gonna have like about 80 batteries, 80 cells altogether. We're using the lithium iron phosphate technology, which is has 4 times more charging cycles than regular 18650 lithium-ion batteries that you use in the cameras. Then we're using battery management system. It's one of the biggest battery management systems. The reason why it's big is because it can conduct 300 amperes, and it's very dangerous current. So that is going to be connected to the motor using this thick wire. It's like thick as my finger. I'm gonna pass it around if you want to take a look at it. It's very heavy as well. And yeah, and the last component we're gonna need is the charger, which is basically charging mechanism. It's gonna be 600 watt. Just in comparison, the regular square cubicle chargers for iPhone, they're 10 watts. So that means that we're gonna have a charger that is 60 times more powerful than regular iPhone charger. And now I would like Patricia Peskevich to talk about the design bodywork.
Hello, for those of you who are new, I'm Patricia, and I'm going to be discussing a little bit about the aerodynamics and air cooling aspects of the overall design. Back here you have 3, but these are actually 2 different concepts. These 2 on the top are the same. This is the first draft and this is the second for the same one. And on the bottom right here is one of the alternative concepts, but we didn't go with this one because it was very similar to an already existing bike close to the Gixxer, and also it's a little too geometrical for us to work with. This one was a little bit simpler, and it would save us more time to go with this first concept. Now, the original front end of the bike was very flat, so a lot of the airflow was restricted. And can you flip this way? Now, our new concept has allows for better aerodynamics due to the front. It's okay. Due to the front fender and the top fender. There's also going to be a half-inch gap in between the side of the front. And this is where the air is going to come in and cool down the inner components of the vehicle. Comfort is also very important for any motorcyclist, so we took that into consideration, and we lowered the back seat a little, I think a couple of inches. Now, the seat was also designed in such a way that there would be a cushion for anybody sitting on it, where no metal or anything would be touching your leg. And also, as you can see here, the entire front end is open, and these slots are placed so no large debris can get in, and there's also going to be a metal wired mesh in the back preventing any minor debris from coming in and destroying anything, like any of the internal compounds. So now that you guys know what our concept looks like, I'd like to pass it over to Usman where he can explain more about our plan.
Okay, hello everyone. My name is Hassan Al-Casey, and for those who don't know, I'm the Vice President of Organization of the STEM Student Union, and today I'm going to be talking about the current goals and our future objectives for this project. So as Misha went over a minute ago, he went over some of the major components of our motorcycle. These components are currently being brought in the mail and we're still waiting on them. And a goal we have for the summer is to have the major components laid out in the way that it is over here. That would be best case scenario. But we expect that once everything does arrive, we're going to have to tweak it and move some things around. It just might not fit in the dimensions of the frame. So in the meantime, while we're waiting for all these major components to come in the mail, we're going to be focusing on the aesthetics of the bikes. We're going to be focusing on the actual bodywork of the bike. So right now, our goal, as of just Monday, we're going to be creating the bodywork out of cardboard. The reason we're going with cardboard is because we want to make sure that we can tweak and design everything efficiently without actually having to 3D print or order any plastic or carbon fiber material. That's going to be a lot harder to work with. So right now, we're designing the bodywork to be aerodynamic, and the goal for this is to create an exact replica of what we want our actual bike to look like in the future. So after we finish constructing the bike out of cardboard, we're going to be taking exact measurements and modifying our 3D model of the bike so that it represents exactly the cardboard layout. So as Patricia mentioned, we want to make sure that we take comfort into consideration. So with this cardboard design, we want to make sure that we can actually, hold onto the handlebars and turn it without, our fingers getting crushed, because that would be not good. But yeah, so that's the goal for the summer, just focusing on the aesthetics and waiting for all the parts to come in and lay them out in such a way that allows everything, the front and the back, to be cooled by the air as we accelerate. And now I'm going to pass it back on to Misha. Let's talk about what I need to talk about.
There's basically nothing here. On this slide, you can see our motorcycle going with the speed of sound, because the stop sign back there is a little bit curved. And yeah, check out our blog at bergenemc.wixsite.com and make sure to put -my site on it, because otherwise it's not going to transfer to that site. And now, thank you everybody for your attention. If you have any questions, we will be more than happy to answer them.